What do we mean when we say body is charged? A typical body don't contain one or two atoms. It contains billions of atoms. So if any one of those atoms is not having as many electrons as protons, we say that body is charged. A typical human body has around 7 into 10 to the power of 27 atoms. So if any one of those atoms is not having as many electrons as protons, then we say that our body is charged. So this body, which is having the more negative charges, is negatively charged. So net charge in the universe is conserved. That means it does not imply that total number of charges are conserved, because one neutron may end up becoming a proton and an electron. For example, this neutron might end up becoming a proton and electron. Here, the total number of charges is not conserved; it is increased, but total charge is conserved because both negative and positive together become a net zero charge. So same case with these four neutrons. Charge is quantized. That means there is a minimum amount of charge that we can transfer or take away from a body, which is a charge of electron. So any transaction that takes place should be an integral multiple of this charge of the electrons. So we have experiment called Millikan oil drop experiment. It kind of confirmed that charge is quantized. That found that minimum amount of charge can be transferred is the charge of an electron. Found that the charge of an electron is 1.60 into 10 to the power of 10 to the power of 19. So unit of charge is coulomb. 10 to the power of 8. That means Coulomb is a large unit. Why we made the Coulomb large unit is because we wanted to make ampere a smaller unit. So we were forced to make the Coulomb as a large unit. If you are thinking proton is a fundamental particle, you are not wrong, but you are not exactly correct. There is something inside the proton which we call as quarks, and there are two types of quarks: up quark and a down quarks. So up quarks contain the charge. Each one of those up quarks contain two-thirds of the charges, and each down quark contain minus 1 by 3. So 2 times of 2 by 3 minus 1 by 3 again gives you the 1. So we cannot transfer up a quark or a down quark separately. So quarks are not isolable, so we can't get a quark separately. We can still stick with the fact that proton is a fundamental particle. Proton, the minimum charge that can be transferred from one body to another body is charge of a proton or an electron. I said about the similarities between force of gravitation and force of electrical charge. There is something different for these two forces. Here we can see G, here we can see Q, here we can see K. G is a universal constant. No matter at what corner of the universe you go and experiment these things, it's same. The force of gravity that you get is same, but it's not the case with force of electrical force. It depends on the medium. That means charges know, kind of know in what medium they are, and wonder by thinking how they know. Thank you.